Hello, I am Olivier from LiveObjects, and today we will have a closer look on a device management feature, remote commands. To follow this session, I assume that you are familiar with Orange LiveObjects. If you are not, please refer to our beginner's video on this channel. We will step through all principles allowing one to send downlink information to devices, usually taking remote actions. Here is a quick reminder of LiveObjects architecture. Today, we will focus only on the blue track from the device management box to the devices. However, many device management events, like a command success status, will step down on the gray link and re-enter the data management and the orange track down to your business application. So, what are our means to take remote actions on our devices? Well, first, some of our devices have published their configuration. This is the case for MQTT and external connector. A user or a business application is able to request a change of these parameters to the device. As soon as the device can get the request, it will decide whether to apply it and send a response to LiveObjects. The same class of devices can usually manage their firmware over the air. Firmware, or more generally any binary resource that the device can alter, configuration file, certificates, libraries, etc. As a user or a business application, you can send a notification to the device that it must get and apply a new firmware. The device may defer the download to accommodate its network constraints. After the binary is locally applied, whatever action it would take, the device acknowledges the firmware update request to LiveObjects. Remote commands are widely available on devices and allows you to send any order to a device. Depending on the device class, the command may be raw binary or structured data. Once the device gets it, it is again locally applied, whatever action it would take. When the device protocol handles acknowledgements, the device commits the request on LiveObjects. Finally, campaigns will allow us to request one of these actions as a batch on a fleet and get a simple-to-read report during and after the process. For this video, we will focus on commands and command campaigns. A command is an order that will be stored in LiveObjects until it can be sent to the device. It can be sent over a connected MQTT-S link, or via LoRaWAN when the device opens a listening window, usually after each emitted frame, or to a GSM device using a downlink SMS, or to a specific device wired via an external connector. When it comes to sending the same command to a whole fleet, a handy feature is the campaign management. It will buffer and dispatch the command to every device over a period of time and provide a success state for them in a report. It could be successes, failures, timeouts, etc. We will see in this video how it works for MQTT, LoRa, SMS, and external connector. Campaigns will apply to one type of devices at a time because command formats are protocol-specific. They will apply to a part of the fleet or even your whole fleet. Here, we will request a filter on a tag to send commands to only music and sports tagged devices. Other devices will not be affected. Let's consider that I give 1 week for the campaign to complete. Now, what if a new music tagged device is added in the middle of the campaign? Well, in static campaigns, the new device will not enter the campaign, whereas dynamic campaigns will consider this device and send it the command. How will I demonstrate those functionalities today? Like in my previous videos, I will use a patched version of MQTT Spy that you can find on olivem-fr GitHub for external connector simulation. Also, I will use a Java codebase available on Data Venue LiveObjects GitHub to simulate MQTT devices. For LoRaWAN, I will use real LSys devices. Let's go! We will start this demonstration using an MQTT simulator. So for it, I have generated an API key on my account that I will copy and paste into this Java program that is available on GitHub and that simulates an MQTT device. So I have to paste the API key I have generated, and of course I will say that it manages at least commands. We could activate the other features as well, but I won't touch these. Let's run that program. So we can see that my program has already published one message, and we will come back to Live Objects, check out MQTT devices. I have created one device and I have the downlink tab. So let's add a command. So we'll give a name to the request. We'll give some arguments. Maybe add some odd one. And we'll see how it works in the program. We have to set a pending state duration. So maybe this one will be available for 1 day. We'll keep the acknowledgement level, a timeout acknowledgement, and that's it. I will validate this command. As you can see, it has already switched to the state processed. And we have a response. So what happens on the Java side? We can see that the device has received a command here on the command topic, which is my command 1. We can see the arguments and a CID, command identification. We can see that my program has acknowledged the message, sending an acknowledgement, whatever it is, and giving back the CID. Therefore, the command is published, and this is why I've got this processed message. I can open the detail here and see the pending state, the processing state, and the process state. I can have the full history with the dates. I can see the answer. That was the full response given by my program. And I have a reminder of what had been sent. Okay, so that was the first example, but we can check what happens behind the scene. So let's go to the network tab. We might repeat this command. Okay. So what happened here? The post has been sent, and in the request we can see what has been sent, all the parameters and the full URL here. So it's quite easy to use it from your program using our APIs. Now, what if in my program here I change something? In the device commands, this is how commands are managed. I subscribe to the topic, and when the message arrives, I prepare a response that I send. What happens if I stop responding to the frame? So here, let's repeat the command. So we see the command that is in the processing state. It has been sent to the device. Yes, the command has been received here. So here I have my acknowledgement timeouts of 1 minute. Meaning within that minute, if I don't answer the command, it will be in the fail state. Okay, we can see now we have an error state, acknowledgement timeout, meaning LiveObject knows that the problem relies in the program in the device. This is why we can set, if I ask for my command 2 here. I can leave the pending state duration for the moment to 1 day, leave the 1 minute timeout, but I will ask for multiple retries. Let's validate that. And let's see, in my program here, I got the my command 2 here and no answer. Let's wait. So we see here that LiveObject has started a new command again here. What happens there? We can see the timeout, the first timeout here, the new try, but we are still in the green state, and let's wait for the end of the 3 times. We're still waiting for the last send command. So this is the last timeout, and LiveObject has stopped trying, and we're now in the error state. Fine. Now, what if I stop my simulator and start a new command? So here I will set a pending state duration to 1 minute and with 1 retry. We see here the pending state. LiveObject knows that the device is offline, so it cannot send the information. We'll show the history and we'll wait. Let's refresh. We have now the expired status. 1 minute has passed and LiveObject knows that it's no use trying to send this command. The device has not connected. Consider the retry has no use here. Retry is only when the device does not answer within the allowed time frame. What if we combine them now? Let's set a command that can be in a pending state for 1 minute and that has a timeout of 1 minute too. And let's retry 2 times. Validate that command, which is in pending state. And I'll start my simulator. So we have subscribed to the channel. We have received the my command 4, but we don't reply. So we'll be waiting here for 1 minute. In the meantime, we're in the processing state. And let's see what happens. We've had a retry here. And in the meantime, we have the expiration of the whole command. So we're now in the expired and timeout status. Of course, if I set a new command now, command 5, whatever the duration, but I ask for no acknowledgement and I validate that. The command is immediately processed. It has been received here in the same formats by my device, but the LiveObject didn't wait for the acknowledgement, so it's processed, and that's it. So let's switch to a little bit more complex setup. On my commands, I will send some commands, but maybe not for each and every device. So I will add, let me add a near random next double less than 0.9. So 90% of the time this code will be executed, which means that I should have around 10% of failures, because in 10% of the cases they won't reply. In my devices, I will ask to send 0 messages. I don't want to pollute, and I will create 100 devices. Let's start that. So each and every device will connect to LiveObject. I will wait for 2 minutes for it to complete. Okay, now I have 100 devices, And so if I want to send commands to them, I won't send them one by one. I will start a campaign. So I will create one campaign on MQTT devices. It's fine, so everything in the root group. Okay, next. I will send a command. And let's say it's my command 1. Again, I can send some arguments. One, several arguments. Doesn't matter. I will set some pending states. I will set 1 minute for it to complete quickly with an acknowledgement. Okay, and that's it. Next. So that's my campaign 1, starting now, ending tomorrow, and complete. So it's already ongoing. We can see there's already quite a large set of success. We'll open this and we see that it's a success on 89 devices. 11 are in progress, meaning that my simulator has received lots of commands and has published many acknowledgements. But we know that for around 10% of them, we asked it not to respond. So we'll wait for 1 minute. And it's done. 11 of them are failed. So here we go. We could filter on failed devices to check and see what happened. And on all devices we can export, open that. We have a bit more information here on when it's been started, updated, what happens on each and every of them. We have seen a pretty nice option during the campaign, which was the ability to send 2 commands. So let's say CMD1, I won't set any new arguments, it's no need. And command 2, it's CMD2 for 1 minute. Next. So this is my camp 2. So I'll make them start right now. I could delay the start of the operation, of course, but that's not the goal here. So the ongoing, camp 2, 78 are okay. If I have a look at the simulator now, I can see that I still have some command 2 arriving. A lot of command 2 here. And we can see also some command 1 beforehand. Coming back to live object, I will wait for it to complete. Okay, my campaign has completed. I can see all the failures, the duration. I will try to export this information just to show you the difference between what we had before. So we have now a little bit more information on operation 1 and operation 2. So we have some devices that did reply to operation 1 but that did not reply to operation 2. The one that failed operation 1 did not even start operation 2. So this is why we have more than 20% failures, and the export allows us to see the details of what happened on which device. Some more options in the campaigns. We could first create a group of devices and maybe move some devices into that group. Move. I will create a campaign on MQTT with group being group 1. Next, send a command, whatever. But I will give it 1 minute to complete. So start date now and end date. I will end it within, let's say, 3 minutes. I will also check on the network to see what happens here. We can see the post on campaigns with the full URL device management campaigns and the request that has been used, the application and all the options and the filter query. So ongoing 19 on 20. One is in failure because of my restrictions on the device side. As it is a static, if I take a device that is not inside the group and that I move it to the group, it has stayed on 20 devices. Now, if I ask for a dynamic campaign, one minute, starting now and ending within several minutes, complete. So it is ongoing with 19 success on 21. What if I add one more device to it? Let's move that. Now we're running with 22 devices and one is not started. Okay, now it has started all of them, and as usual, my around 10% of failures. We can see that it's still in the running state because it doesn't know if some more devices are going to be added before the end, but I could anyway cancel it. If I want to see the details of those, I can always come back to devices and check, for example, here, my device one, go to commands, and I will see all the commands sent from my campaigns and check the results, for example. I am switching now to SMS devices. I have created an SMS device with my phone number. I will add a command. I could send text or binary, but my phone would only display text messages. So let's send a command. It's been processed and received. Let's try with some binary. So here it's processed, even if my phone says that this content is not handled by this application. Finally, I can create a campaign on SMS devices. From campaign. SMS campaign 1, starting now, ending tomorrow. Yeah, it's already completed. 100% success within a few seconds. As for LoRa devices, I have created here an Explorer 2 device, and I can send downlinks to. So we'll add a command. Let's send some hexadecimal payload. Enter the port according to your device specification, some expiry time, and an acknowledgement again if you want no acknowledgement, or if you want a confirmed downlink sent to the device. Let's validate that. So my deadbeef is pending, meaning it's actually in the core LoRa network, waiting to be sent to the device as soon as the device will send an uplink. So here the command has been sent to my device, and I wait that my device sends back an acknowledgement. If I want to make sure, I can check in the logs. I can see my deadbeef downlink with all detailed information here. So it has not acknowledged the command. So it will stay in the processing state for 5 minutes until it will ultimately fail. So let's send another example on port 1. So this one will be stacked, waiting for the result of the previous one. So now this one is in timeout state. This Cafe Baby is actually pending. It's been processing, and we're waiting for the confirmation. So now the device has sent a confirmation to this Cafe Baby payload. It's included in the next uplink, which allows LiveObject to say that it's processed. I can request a command to be sent. It will be sent to the LoRa core network. Now, what if I want to cancel these commands? I can use this cancel button. LiveObject will go and fetch in the core network the command to cancel it. So now it's been properly cancelled. If I want to cancel a command, so let's resend some deadbeef command. If I want to cancel a command that is actually in processing state, I will be asked to force it because my device has received the order. So I don't know if the device has taken some action or not. So LiveObject asks me to force this cancellation. Of course, for LoRa devices, I can also set campaigns. It will be the same format as before, and send some cafe for 1 hour. No confirmation is fine, and next. Ending 17. So the progress will take much more time than before because LoRa devices hardly communicate with the network. So I'll have to wait that each and every device actively communicates on the network. And some of them actually won't communicate because they're not alive now. So 2 of my devices didn't make it, so whatever, it's cancelled here, and I'll get a success state on all the others. Now if you want to do that with external connector, get a new key for external connector, configure an MQTT SPI, LiveObject connector using that key. No publication, but I've got subscription to commands. So let's apply that. Open connection. So I have my connector opened. My request/commands topic is subscribed. Now I have some external connector scripts that you have seen in my other videos. So I can start X connector here and see on LiveObjects the results. So I have this device, I have commands, with again some arguments and values I can add, some pending state. Well, I would say no acknowledgement yet. Validate. So the command has been pending, processed, because my connector is online. And on the connector, I can see the whole commands with the interesting thing that it's the node ID and the ID that I will have to use if I want to acknowledge this. Now, if I start a new command, let's give it 5 minutes to answer, 5 minutes for acknowledgement. We can see that it's been processing and processed with some status and some message. And this is because I have this command ACK auto script. So let's see how it's done. If I want to manually acknowledge a command, I should ask MQTT publish in the response command topic, but I should use the ID here. So I will be using auto acknowledgement. It will reply 90% of the time. So it will pass the payload and reuse the node ID here. So let's see what happens if I have many devices. Let's check on LiveObjects. So now I have 201 devices on external connectors. So let's try a campaign on this. For all of them. Send the commands from campaign, 1 minute, and next. Next campaign. So I have 178 devices that have declared a success, 23 failure. So remember that I have this automatic failure in the answering. And if I have a look at MQTT Spy, I've had 201 messages. I could go through them. As a conclusion to this video, I'd like to remind you that campaigns are visible in the activity and access logs. You can see here my latest campaign as it's been created. You can see in the activity logs the actual thing going, and in the data, let's create a FIFO. In my routing rules, I will be able to ask for command status events to be sent to my FIFO. As you can see, I could filter on the type of messages, but let's say I'd like to keep all of them. And this is a forwarding rule for command status. So using an app key, an application API key, an MQTT Spy configuration, so I will not subscribe to those. I will subscribe to and I will send a message Okay, so here I've had 2 messages. So my 2 comment status have been received. So one with the state processing and one with the state processed with all the detail that I've had from my external connector. So this way you can get all the comment status events in your own application and warn your users or update your HMIs or whatever you want. I wish you a lot of fun using the commands and the campaigns management in Live Objects, and wish to speak to you soon. Bye-bye.
Orange.